Today we're going to look at adding mixed numbers with unlike denominators. So mixed numbers, just as a review, okay, is when you have a whole number. So a mixed number, that's right, you have the whole number and a fraction. So that's things like 1 2/3 or 6 3/8, right? The whole number and fraction, mixed, okay? So when we're adding, it's important to remember what these whole numbers represent. So for this fraction right here, 1 2/3, that one, really, if we were to draw a picture, we'd have 1 2/3, right? So we would cut that. Here's our 2/3. This one whole is really 3/3, okay? That's where this comes from, okay? And this is important to remember, okay? That one is really a 3/3, okay? Just like over here, this 6 wholes is made up of, if our denominator over here is 8, that's 1 8/8, 2 8/8, 3 8/8, 4 8/8, 5 8/8, and 6 8/8. Okay? 1 2 3 4 5 6. 6 wholes, right? But like we've said before, our denominator represents how many pieces make up a whole, okay? So that's where that comes into play. So if we are looking at a problem, I'm going to draw a little line here. Let's say 1 3/4 plus 1 1/6. Okay. How I like to set these up is I like to think back to when we first learned how to add, when you were a tiny little kid in like first, second grade. And I like to line up all my whole numbers and my fractions on this side. Just like if I were to do tens and ones or whole numbers and decimals, right? Because fractions are really decimals. That's all this is, okay? And I know, right, we're adding, so I'll put that back in my bar to add. And I'll rewrite my problem. I have 1 3/4 plus 1 whole and 1/6. Okay? I haven't changed my amounts, right? They're still next to the same one, 1 3/4, 1 1/6. They're just lined up. Okay? Whole numbers and whole numbers, fractions and fractions. Now, what this allows me to do, especially when there's different denominators, is I can focus just on these parts rather than the mixed number together. Because it does not matter how I rewrite these into equivalent fractions, this whole is still one whole, right? If you have one pizza, it does not matter how many pieces you cut it up into, that is still one pizza regardless. So I'm not going to even worry about these whole numbers here. I'm just going to focus on the fractions. Okay? All right, you'd have to find that LCM, which is going to be 12 for this one. So I think, how does this become a 12 and this become a 12? 6 times what gives you 12? Times 2, right? And we know that means we need to multiply by 2/2 to make 1/6 become 2/12. I'm going to do the same up here. How does a 4 become a 12? Times 3. If that's multiplied by 3, so is the top. So we have 9/12 and 2/12. Now we can add these just like that. Okay, 9 plus 2 is going to give you 11. Denominators don't change. 11/12. Whole numbers, 1 plus 1, 2. Which makes your answer 2 and 11/12. Okay, let's do one more example of this together. Okay, so let's say we have the problem 3 and 1/2 plus 1 and 3/4. Okay, two mixed numbers, different denominators. Again, I'm going to line that up with my whole numbers, fractions, and this is going to be the basis of how we do subtraction as well. So that's not going to change. Have our lovely little chart. We like to keep it organized. And we know we are adding, so we need to put our bar in to remind ourselves that we're adding. Okay. Now we write our fractions in. 3 and 1/2, 1 and 3/4. Okay. Whole numbers and fractions. As we can see, our fractions do not have the same denominator, so we need to fix that. Your LCM of 2 and 4 is not 8, it is 4. Right? If you were to write these out, 2, 4, 6, 8, 4, 8, 12, They share this 4 before the 8 because we can only change one of these and still get a common denominator. So 3/4 does not have to change. He can stay. We're going to look at this one, 1/2. Okay, times 2 times 2 to give us 2/4. Okay, now we're going to add these. Denominator stays the same, 1/4. 2 plus 3 is 5. Come over here. 3 and 1 is 4. Now you're looking at this, you say, whoa, hold up. That's an improper fraction. So let's fix this. 5/4, 1, 2, 3, 4, 5, grouped by 4 is really 1 and 1/4, which means this 1 can pop over here, and this will become 5 and 1/4. Okay. You could also, if you get this and you want to change it right away and say, oh, this is 1 and 1/4, just like you would carry over when you're adding in a base 10 system and put your 1 right here and get 5 that way, you can do that same thing.